Hello, everyone. I wanted to make a quick video for you for a couple of kind of oddball odds and ends here in section 3.3 that we didn't get to in class. There's just a couple of um, problems in here that um, will make a couple of problems in your homework a little bit easier. So I wanted to start with this one here, number 8. M of x is equal to e to the x times the quantity 3x plus 1 times the quantity 2x minus 7. Um, so with this one, we're trying to find the derivative, m prime. Now we have three things being multiplied, right? E to the x times 3x plus 1 times 2x minus 7. We've got two different multiplications happening here. So to find the derivative, what we're going to do is have to do a product rule. Now you're going to have to decide which is your f, your first function, and which is your g, right? Or yeah, your second function. And it's really up to you. You can kind of decide how you want to do this. The way that I'm going to do this today is that I'm going to take these first two together and I'm going to call that my f, or my f of x. And I'm going to take the second one as my g. Okay, so if I do that, and this is my first one and g is my second one, then to find the derivative of m, I'm going to do the derivative of the first one times the second one as is, plus the first one as is times the derivative of the second one. So we're going to have to start with the derivative of f. Now, when I take the derivative of f, I have a product inside f. So when I do f prime, I'm going to need a product rule inside that one. Okay, so when I do that, e to the x is going to be my first one. 3x plus 1 will be my second one. Okay, so f prime of x, the derivative of this first one, is going to be the derivative of e to the x. That's e to the x times the second as is. That's 3x plus 1 as is, plus the derivative of my first, which is the derivative of e to the x is e to the x. Or sorry, this was the derivative of e to the x. Derivative of e to the x. This was the second as is. This is my first as is, and this one is the derivative of 3x plus 1. Okay, so the derivative of 3x plus 1 is 3. There we go. So all of this is f prime of x, right? The derivative of the first times the second as is, plus the first as is times the derivative of the second. Okay, so we did all of that. That is just f prime. Now we're going to multiply that by my g of x as is. That's going to be the 2x minus 7. And then we're going to add that to f of x as is, which is e to the x times 3x plus 1. And we're going to multiply that by the derivative of g prime, which is 2. So here we have a product rule inside a product rule. Okay, so we have all of this, and now we just need to do some simplifying to make this look a little prettier. So I'm going to go ahead and distribute this e to the x. So over here, I'm going to get 3x e to the x plus e to the x. And then I will add these two. So I'm going to have plus 3 e to the x. I'm going to have all of that times 2x minus 7. And then over here, I'll distribute that e to the x. And I will get 3x e to the x. I want to write that in a different order. So I get 3x e to the x plus e to the x, and we'll have all of that times 2. Now here we've got like terms. So 1 e to the x plus 3 e to the x. This is going to be 4 e to the x. Instead of rewriting everything, these are the only things that combine. So I'm just going to get lazy here for a second and just combine that here. Okay, so from now, I'm going to FOIL all of this out, and I can do in first, outside, inside, last. And so I'm going to get 6x squared e to the x minus 21x e to the x. That's my first and my outside. And then I'll do my inside, which is going to be plus 8x e to the x. And I'll do the last, which is minus 28 e to the x. And then I can distribute this 2 here. So I'm going to have plus 6x e to the x plus 2 e to the x. Okay, the worst of this is over. Now we're going to see if we can find some like terms here. So do we have any like terms? Well, let's see. I have this x squared e to the x, but not another one. Here I have a negative 21x e to the x. I've got another x e to the x, and I have a third e to the x. So I can combine all of those. And then I have just a number times e to the x and a number times e to the x. Those are also like terms. So now I can combine these guys, and I'm going to get 6x squared e to the x, negative 21 plus 8 minus 28. Let's see, this is going to be negative, so plus 8. Oh, wait, no, that's just kidding. This is with something else. So it's the negative 21 plus 8 plus 6. Sorry, my brain doesn't want to do that. So negative 21x plus 14x, that's going to be plus 7x e to the x. There we go. Sorry, all my brain doesn't want to do this. And then negative 28e to the x plus 2e to the x is minus 26e to the x. Perfect. So you can write your final answer like that. We've combined all of our like terms. Or if your brain wants to factor out that e to the x to make it look pretty, you can do that way as well. Nothing simplifies or cancels, so both of these are equally simplified. It just depends on what your brain likes best. So that's kind of how I would go about this. Choose your F and your G, and then you'll just have a product rule inside a product rule. So that is how I would tackle that one. All right, this one, I'm going to do this guy in class because that is something that I want to have us start practicing. So I'm going to do that one in class to make sure that everyone sees that one. So I'm going to do that on Wednesday. So let's move on to number 2 here. I want to write the equation of the line tangent to f of x at x equals 0, where f of x is 1 plus 2x plus x e to the x. Okay, well, I want the equation of the tangent line, which is the equation of a line. So to write the equation of a line, you need 2 things. You need a point on your function, and you need a slope. Sorry, point on your line and the slope of your line. So let's start with point. We need a point on my tangent line. We know we want the equation of the tangent line at x equals 0. So I know that's going to be the x value of my point. And now I need a y value. The point on my function at x equals 0 is both a point on my function and a point on my tangent line. So to get y, I'm going to plug x equals 0 into my function, and I'm going to get 1 plus 2 times 0 plus 0 times e to the 0, which is 1 plus a bunch of zeros, which is just 1. So that means the point on my function is 0, 1. That's my x and my y for my point. Okay, so that's the point on my line. And now I need a slope. What tells us our slope? The derivative. You're right. So I'm going to need the derivative. So what's the derivative of f of x? Well, we're going to find the derivative of this guy. The derivative of 1 is 0. The derivative of 2x is 2. The derivative of x times e to the x, you're right, that's a product rule. So I'm going to have to do the derivative of the first, which is 1, times the second as is, that's e to the x, plus the first as is, that's x, times the derivative of the second, which is the derivative of e to the x is e to the x. So that is my f prime of x. We don't really have much to simplify here. We can just write it as 2 plus e to the x plus x, e to the x. That's my derivative. So how do I find the slope of my line? Well, this tells me the slope at any x value, and I want the slope at x equals 0, so I'm going to do f prime of 0 to get the slope of my line. So when I plug 0 into my function, I get 2 plus e to the 0 plus 0 e to the 0, which is 2 plus 1 plus 0. That's 3. So I know that my slope is 3. And I have my point, which is my x and y, and I'm going to plug all of that into y equals mx plus b. Again, if it's in your repertoire and you'd rather use point slope form, you can do y minus y1. Let me rephrase that. Okay, y, just kidding, I don't need the 2 there. There we go. Y minus y1 equals m times the quantity x minus x1. There we go. You can use either one of these. We've been using y equals mx plus b in class, so I'm going to stick with that. So our y value is 1. Our slope is 3. Our x value is 0 and plus b. So that means that b equals 1 and y equals mx plus b. To write the equation of our line is y equals 3x plus 1. That is the equation of our tangent line. And this will pretty much always be your process for the equation of a tangent line. You're going to plug your x value into your function to get y. You're going to plug your x value into your derivative to get slope, and then you'll use y equals mx plus b. Okay. And then I want to do one last one. So we have a manufacturer determines that T months after a new product is introduced to the market, the demand for the product, which is the number of units sold, is given by this thing. X of T equals T squared plus 3T 100 units. When it is sold for a price of P of T equals negative 2 T to the 3 halves plus $30 per unit. Okay, I have two functions here. I just like to do a quick input-output check here. So X of T is, what's going into this? T is my input. T is months. So I put in time and months, and what I get out is X of T, which is the number of units sold. So I put months in, I get units out. The units sold. This guy over here, P of T, again, my input is T, which is time in months. So again, I am putting months in. And what am I getting out? I'm getting P of T, which is the price per unit out. So I'll say price per unit out. Okay. So that's what I've got two functions. I want the revenue for this product as a function of time. Okay, revenue. Revenue is cash money. How much money is coming in from the sale of these units? How do I get money? Well, I have price per unit that they're selling for, and I have the number of units sold. How do you get dollars per unit and I have units sold? How do I get dollars out of this? Well, if we take the amount of money per unit and multiply it by the number of units sold, then basically the units will cancel out and I get the total amount of money that was brought in, right? The dollars per unit times the number of units sold will give me an amount of money that came in. So this is R of T. That's my revenue. My units sold, this is my X of T. And my dollars per unit, this is my P of T. So if I multiply P of T times X of T, I get my revenue function. Okay, so R of T is going to be P of T times X of T, which is going to look like P of T is negative 2 T to the 3 halves plus 30 times T squared plus 3T. That's my X of T. This is what my revenue function looks like. So here is my revenue function. Okay, so for the second part, we are asking at what rate is revenue changing with respect to time after 4 months? Is the revenue increasing or decreasing? Okay, I want to know the rate at which the revenue is changing. This is a rate of change of the revenue, right? At what rate is it changing? That's a rate of change. Rate of change means slope, and slope means derivative. What I'm being asked for here is the derivative of revenue after 4 months. Well, after 4 months, that's a t value, right? T is in months. So this is a derivative at t equals 4 after 4 months. Okay, so I'm going to find r prime of t first. I'll find the derivative, then I will plug t equals 4 in. To do this, I'm going to use the product rule. So I'll do the derivative of the first. So I'm going to do negative 2 times 3 halves t to the 1 half plus 0. The derivative of 30 is 0 times the second as is plus the first as is, negative 2 t to the 3 halves plus 30 times the derivative of my second here, which is 2t plus 3. Okay, so now I'm going to simplify this a little bit. Negative 2 times 3 halves. I'm just going to go ahead and simplify this a little bit and call this negative 3. If you want to rewrite it all, you're welcome to do that. I'm just going to simplify that a little bit um, just to be able to finish this. And then from here, I'm going to go ahead and distribute. So I'm going to get negative 3 times t to the 1 half plus 2 is 2.5. That's 5 halves. Minus 9t to the 1 half plus 1, which is 3 halves. And then I'm going to add to that whatever I get from this foiling. So I'm going to FOIL this all out. When you multiply the first, you're going to get negative 4t to the 3 halves plus 1, that's 5 halves, minus 6t to the 3 halves plus 60t plus 90. Okay, so now I'm going to take a look here and see, do I have any like terms? Let's see, I've got t to the 5 halves. I've got some t to the 3 halves, and I think that's it. So then we'll combine like terms here. My 5 halves, negative 3 minus 4 gives me negative 7 t to the 5 halves. And then my t to the 3 halves, negative 9 minus 6 is minus 15 t to the 3 halves plus 60t plus 90. Okay, so this is my derivative, and I want to know what my rate of change is, what my slope is at t equals 4. So I'm going to find r prime of 4 and plug that in. So I'm going to get negative 7 times 4 to the 5 halves minus 15 times 4 to the 3 halves plus 60 times 4 plus 90. You can put all of that into your calculator And you are going to get, this is going to be negative 224 minus 120 plus 240 plus 90, and you'll put all of that in your calculator and you're going to get negative 14. So what does that mean? Well, that means the rate of change of the revenue. So R prime of 4. The way that my revenue is changing is negative 14, and the units of this are the units of Y per unit of X. The units of Y in R, that's my revenue, that's going to be dollars per unit of X. My input value here is T, and T is in months. So this is going to be dollars per month. So after 4 months, my revenue is changing by negative $14 per month. So does that mean your revenue is increasing or decreasing? Yep, that means that our revenue is decreasing by $14 per month. Okay. Hopefully that helps you with your homework in section 3.3. Have a lovely evening, and I will see you next time.